ম্যাম, হ্যালো।
হ্যাঁ বল। হ্যাঁ,
হ্যাঁ, বলছি যে ম্যাম 31st কি আপনি আমাদের ক্লাস নেবেন?
তোমরা না করতে চাইলে তো নেব না।
না না ম্যাম, আসলে সেটা না, আসলে আমাদের ল্যাব শুরু হবে তো নেক্সট উইক থেকে, তো 12টা থেকে ল্যাব আছে অনলাইনে। তো সেই দিন যদি ক্লাসটা আপনি একটু কাইন্ডলি আগে থেকে নেন, মানে 9:30 থেকে নেন, 1 ঘন্টা আগিয়ে দিয়ে।
আচ্ছা, আমি 10টা থেকে নিই, 11:30টায় ছেড়ে দেবো।
হ্যাঁ ম্যাম, তাহলেও হবে।
ঠিক আছে, তাহলে পরের দিন হচ্ছে 10টা থেকে দেবো, ওকে।
না হলে ম্যাম একবারে ওই 12টা থেকে ল্যাব আছে আর তারপরে আমাদের আবার ক্লাসও আছে, তো প্রবলেম হয়ে যায়।
ঠিক আছে, আমি তোমাদের 10টা থেকে নেব, দিয়ে ছেড়ে দেবো, ওকে।
ওকে ম্যাম।
এই স্ক্রিনটা কি দেখতে পাচ্ছো? দেখো তো।
হ্যাঁ ম্যাম, দেখা যাচ্ছে।
ওকে। Okay. So, till now we have solved the differential equations uh, where there were only one dependent variable and one independent variable, that is like y and x. But there are some other ordinary differential equations where the independent variable is one, say single one, and your dependent variable say two. It may be more than one, okay. uh, your independent variable will be one, but your dependent variable may be more than one, and your number of equations will be simultaneous equations will be the equal to the number of independent variable dependent variables. Okay, suppose I have a two dependent variable which depends on t, so then we will have two simultaneous differential equation, and we will consider here only first order, like okay, here both x and y are dependent on t. So we will solve these two equations simultaneously and we'll get a solution x in terms of t and a y in terms of t, satisfying these two conditions. And it is pretty easy. You already know probably this type 2. Suppose I have from this, I will get y is equal to 7x minus dx dt. So I will replace this in this equation. So I will get ddt of 7x minus dx dt minus 2x minus 5, 7x minus dx dt is equal to 0. Your right side may not be 0. In some equations, there may be some functions of t, and or you will get a second order differential equation, and probably you will be able to solve this kind of equation, like if I multiply if I operate ddt on this, so this will be 7 dx dt minus the first term will be minus d2x dt square 7 dx dt, and here is 5, uh, so that will be okay. I may plus 7 dx dt minus 2a 35x plus 5 dt is equal to 0, or d2x dt square minus 12 dx dt plus 37x0. And now you can solve this differential equation. This is nothing but the auxiliary equation is m square minus 12m plus 37 is equal to 0. So your m is put over 4 into 1 into 37 by 6 plus minus, this is 148, so this is minus 4, that means 2i, so this will be I. Okay, so the solution of, we had the equation in d2x dt square. Okay, so this will be, our x will be e to the power 60 a cos t plus b sin t. You know, if the root of this is a complex root, then your solution will be like this. So this will be x. So you know your dx dt, and you will substitute in the given equation in terms of, uh, you will substitute x and dx dt in this equation, and you will get your y. Okay. So your dx dt is e to the power 60 minus a sin t plus b cos t. This is nothing but 6x. Okay, so substituting in the given equation, which is dx dt minus 7x plus y is equal to 0. So I will get my y as 7x. So 7x is this, minus 6 is this. So I will get my y as x minus e to the, yes. Okay, and you can substitute your, the given equation is dx dt, y is, implies y is 7x minus dx dt. Acha, this dx dt is this term plus 6x. Okay, so this will be minus 7x minus 6x. So that will be x minus of dx dt. Okay, this term. Your x is e to the power 60 a cos t plus b sin t. Cos t is a minus b cos t, and this will be a plus b sin t. So you can put this is c1, and you can put this is c2. So your y is given by this, your x is given by this. So you got the solution. Now if you have a equation like, yes, because this is an homogeneous equation, your right side is
0.
0. You don't have the particular part. Okay, I am giving you an example so that you have a particular integral part. So this is one sec. Suppose uh, dx dt plus 5x plus y is equal to e to the power t, and dy dt minus x plus 3y is equal to e to the power 2t. Okay, so you will either you can replace x from this, or you can replace y from this. Okay, so whatever you choose, that is your choice. Suppose I am choosing x from this equation, that is x is dy dt plus 3y minus e to the power 2t. I am replacing this x here. So this will, I will directly writing, that is operating ddt on this. So this will be d2y dt square plus 3 dy dt minus 2 e to the power 2t plus 5 dy dt plus 3y minus e to the power 2t plus y is equal to e to the power t, or d2y dt square plus, this will be 8y, and I am replacing here. So 8y 9y minus 7 e to the power 2t I have done something wrong or something like that.
So to
I
16y.
Oh, this will be 5 into 3, 15, then this is 16. Okay. Okay, so you know the auxiliary is, this is very simple. This will be d plus 4 whole square operated on y is e to the power t plus 7 dt. Okay, so first you know how to calculate the CF, and then we have to calculate the PI, and from Y then I will substitute this Y in place of X and I will get my X. Okay, so can you solve and tell me whatever you got? Solve it. You have to find out both CF and PI.
Hello, ma'am.
Yes.
The answer will be what- complementary function will be C1 plus C2x times e to the power minus 4x.
C1 plus C2. This is
X.
in Y or X. X. This is X. Alright. E to the power minus 40.
Okay, C1 plus C2, that is x, sorry. And Pi will be e to the power t by 25 plus 7 times e to the power 2t by 36.
Okay. 7 e to
That
the
will
power
be
2
x.
by 36 plus
E to the power t by
7 by
25.
25 e to the power t. Right?
And then, yes, ma'am.
So this is your
X.
Y. This is
No,
your X or Y.
so you say y.
This was in terms of Y, so this will be your Y. Okay. So putting this value, you will get the. So this is your Y is equal to this, right? So this is T.
Ma'am, this will be T.
Yes,
What is
Yes,
this?
ma'am. X is a function, Y is a function of t, so that
T.
will be
This will
C1
be
plus
T.
C2t.
This will be T. Okay, so Y will be this. Okay, CF plus this. And then you will put this value of Y in the first equation, dx dt. Or, oh no, you can put this in the this equation, so you will get your X here. So you will differentiate and tell me the result. It will be in terms of this only. So what is your x?
Ma'am, is it e to the power minus 4t multiplied by some constant into t minus 1 plus some constant plus 2 e to the power t by 25 minus 15 by 36 e to the power 2t?
No, this part will be 4 by 25 e to the power t minus 1 by 36 e to the power 2t. Okay, this x will be this particular integral, and e to the power minus 40 c1t, and this is minus 1. So this minus c1 and plus c3 may be another constant, or there is something multiplied here. No.
Is it C2 minus C1 minus
C2,
minus C1
right,
minus C2T?
minus C2t.
Yes.
So you can take this is another C2 minus C1 is another, maybe considered as another constant, right? So there will be some constant plus C2 into t e to the power minus 40. There will, the form will be like this. And you have got this particular integral 4 by 25 and minus 1 by 36.
Yes, ma'am. Yes.
Okay.
Ma'am, I have
So
a question.
yes.
Ma'am, you have solved this by this method, ma'am. Can we also solve it by Laplace transform in exam?
No. Right now you cannot use Laplace transform. Okay. If probably it won't be mentioned. So okay, if you choose to, then you can do, no problem. If not mentioned otherwise, suppose someone is instructed to solve it by some definite method, then you have to use it. Okay.
If no method is mentioned, then we can do it in.
Yes, if no method is mentioned, you can use any method you know. Okay. So we have completed our ordinary differential equation portion. Okay. So next we will move to partial differential equation. Okay. Suppose I have z which is dependent on xy. For ordinary differential equation, your number of independent variable was 1. But for partial differential equation, we will have our number of independent variables will be more than 1. It may be 2, maybe 3. For simplicity, now we will use only 2 independent variables, and there is one dependent variable z fxy. Then your partial differential equation will have definitely the derivatives with respect to both x and y. Any type, this type of so this is a very general form. Your function which will contain the differentiation with respect to both the independent variables, that is your z on x on y, maybe second order, maybe some higher order. So this will be your general form. And in general, there is a convention that we write this first order derivative, partial derivative of z with respect to x as p. This is q. R is And it is same as if you operate on first y then x, or you operate on this means you are operating z. First you are operating z by y then x, and it is first by x then y, but this will be same. So this is the same notation. And t, this is the convention. We just write pq. So in place of del z del x, you will find this term pq.
ম্যাম টি এর জায়গায় ওটা ওয়াই হবে, ডেল টু জেড বাই ডেল ওয়াই টু।
Yes.
ম্যাম ওই যে টি এর ওখানে ওটা ডেল টু জেড বাই ডেল ওয়াই টু হবে।
Sorry, this will be y, right? Okay. Now, if we write our first order partial differential equation, it will contain only right? It will contain only the first order coefficients, and this will be our general form of first order partial differential equation. This is P, this is Q, and suppose you have a differential equation like this. This is second order partial differential equation. It's the order is the same as before, that is the order of the highest differential coefficient. Okay, and we will first consider first order partial differential equation. Now, how do you form a partial differential equation? Do you remember that for ordinary differential equation, the number of arbitrary constants is the number of the order of the differential equations, and we have eliminated, suppose you have a relation containing two arbitrary constants, then we have eliminated those arbitrary constants and found out the ordinary differential equation. Similarly, suppose I have a function in x, y, z, where z is dependent on x and y, and some arbitrary constants a and b is equal to 0, that is a relation between x, y, z containing two arbitrary constants, then we will eliminate these a and b and we will get a partial differential equation. That is how we form a partial differential equation. That is, suppose I have a relation like, okay, let me check. So differentiating with respect to x, we find again differentiating with respect to, this is x, and with respect to y we will get 2z del z del y is equal to 0, that is x minus a plus zp is equal to 0, or a is equal to x plus pz, or I will get y minus b plus zq is equal to 0. So your b will be y plus zq. So I will substitute this a and b in the given equation. Then that means the equation will be eliminated by a and b. So I will get x minus a whole square. So this will be p square z square. Y minus b whole square will be z square q square plus z square is equal to 1, or z square is equal to p square plus q square plus 1 is equal to 1. So this is a partial differential equation containing z and the partial derivatives. Okay, so solving this, definitely we should get this. Okay, now another is eliminating arbitrary functions. That is, suppose I have a function which is of u and it is an arbitrary function related with u and v. Your u is a function of xyz, your v is a function of xyz, and your z is dependent on x and y. Then we will see that from this relation we will found a partial differential equation, and that will imply that this will be a solution of a partial differential equation where we will find out this u and v for some constants. If our given equation is second order, we will get two constants. So suppose your phi is a function of u and v, and your u and v are functions of xyz. So if we differentiate this partially with respect to u and v, partially means first time I will differentiate with respect to x, keeping y constants, and next time differentiating with respect to y. So first del phi del u, and I will have del u del x. You know how to differentiate partially?
Yes, ma'am.
Okay, so then you know how to differentiate this. Suppose it is a function of okay. I am first differentiating with respect to x. U is a function of both x, y, z.
del u by del z into p হবে এটা।
Okay, so I can simplify writing del z del x p in place of this. So I will get, okay, I am just eliminating here, just removing. This will be p and this will be q. This is p, p, q, this is q. Okay, so if we eliminate this del phi del u and del phi del v from these two equations, you know we will get the determinant as 0. If we eliminate these two, del phi del u, del phi del v from these two equations, we will get this determinant is equal to 0. So I will multiply, you know how to calculate the value of a determinant, that is, it will be these two minus these two. So I can write this as so I will multiply these two and subtract. That means this PQ will be removed. Del U del X, del V del Y, del U del X, del V del Y. Okay, I have to multiply all the terms. Okay, so I have to P del U del Z, and please follow whether I made any mistakes in multiplying. P del U del Z, del V del Y, and then del U del X plus Q del U del X, del V del Z, and PQ del U del Z, del V del Z, minus del U del Y, del V del X. P minus P del U del Y, del V del Z, minus Q del U del Z, del V del X, minus PQ del U del Z, del V del Z is equal to 0. This will be, so you will have a coefficient P, if we can take the common P, so the coefficient of P will be this minus this, Q coefficient will be this minus this, and I can write this equation is capital PP plus QQ is equal to R, where P will be given by this minus this, okay? So your P will be this minus this, capital Q will be this minus this, and your R will be this minus this. So this will be all in terms of, you can see this is all in terms of X and Y and Z. So your P, Q and R all will be in terms of Ux, Vy. So you'll be containing in terms of X, Y, Z. This form Lagrange form. Okay, now we will use how to solve this type of first order partial differential equations when it is given in this form. And you can see, since it contains P and Q, so this is an partial differential equation, and its solution is phi uv is equal to 0 from these we have got this partial differential equation where you have to find out this u and v equal to constants, and you will get the solution as, so when your partial differential equation of first order is given in this form, then we will solve in this method. That is, we will, okay, and I am writing the auxiliary equations for will be given by this, but how it comes, it can be proved. I can give you the proof. Your u is with respect to x, it is total differential del u del z dz is equal to 0, del v del x dx plus del v del y dy del v del z 0, from which you know how to solve this. So your dx will be del u del y del v del z minus del u del z del v del y. Your dy by this will be del u del x del v del z minus del u del z del v del x, and your dz by will be del u del x del v del y, and this is basically nothing but what we have found is this p is this, q is this. So whenever your differential equation in this form, we will write the subsidiary equations and solve it, and it is a very easy method. So that's why, suppose, okay, let's start with a very simple problem. Solve xp plus yq is equal to z. Okay, probably I have given you the definition for this is p, q, z. This is a linear differential equations. All the or is p, q, z all in the order O1. The coefficients and p and q have the coefficients only in x and y. Partial differential equation of first order, and it is in the form this. So I will write my subsidiary equations as, this is p is x, your q is y, and your r is z. So I will take any two of the relation, that is dx by x or di by y, and you know, you will integrate and you will get x by y is equal to c. So this is your u, one integral of phi uv is equal to 0. You have to find out 2 u and v. So this is your first u is, and you know your u is a function of x, y, z. Your v is a function of x, y, z. So this is your u. And the another one will be, you can take any two, dx by x, dz by z, or so I am taking here dy by y is equal to dz by z. So it will be y by z is equal to c2. So y by z is equal to 0. Hope you have followed the method. It is a very easy method. Okay. Hello. Is it okay for you?
ম্যাম y বাই জেড কেন নিচ্ছি ওই জায়গাটা বুঝলাম না।
কোথায় y by z কোথায় নিলাম?
মানে x বাই y ওটা u হলো, যেহেতু u ইজ এ ফাংশন অফ এক্স ওয়াই, সো ম্যাম v v ইজ এ
Ma'am,
ফাংশন অফ, ওকে
ma'am,
ওকে
it
ওকে,
can be x by z also.
yes ma'am.
U is a function of xyz, v is a function of xyz. Sometimes it happens, it all the terms may not be present in u or v. Okay, it is xy, it may be, it could have z here, maybe in some, this is a very simple problem. You will have some problems where this integration is not so easy, and now you know you have to solve any
ম্যাম
two.
জেডটা ইন্ডিপেন্ডেন্ট না ডিপেন্ডেন্ট ভেরিয়েবল এখানে?
জেডটা তো ডিপেন্ডেন্ট, ইন্ডিপেন্ডেন্ট ইজ এক্স অ্যান্ড ওয়াই, নইলে পার্শিয়াল ডিফারেন্সিয়েশনটা হচ্ছে কি করে?
তাহলে ম্যাডাম এখানে মানে আমি যখন ফাই এর এক্সপ্রেশনটা লিখছি তখন জেডটা রাখছি কেন? এক্স আর ওয়াই দিয়ে রাখা যাবে না শুধু?
না, এক্স আর ওয়াই দিয়ে রাখা যাবে না শুধু, সেই জন্য মানে যেভাবে ফরমেশনটা হচ্ছে ওটা জেড এলিমিনেট হচ্ছে না, হতেও পারে কোনো কোনো প্রবলেমের জন্য, কিন্তু ইন জেনারেল ওটা হবে না, কারণ আমার ইউ ইজ আ ফাংশন অফ এক্স ওয়াই জেড। সেটা আমার যেহেতু সলিউশনে যদি ইউভি বোথ আর প্রেজেন্ট, দেন ইউর জেড ইজ প্রেজেন্ট. Basically your solution is a okay, suppose okay, for ordinary differential equation the solution in terms of x and y, and your y is dependent and x is independent, then you never asked why y is there.
ম্যাম হ্যালো,
Hello.
হ্যাঁ ম্যাম, তাহলে এখানে জেডটা কি পেয়ার অফ স্ট্রেট লাইনকে ডিনোট করছে?
না, বেসিক্যালি এটার যে সলিউশনটা হবে এটা 2D তে সারফেস রিপ্রেজেন্ট করবে।
আচ্ছা ঠিক আছে ম্যাম।
এটা সারফেস,
আচ্ছা ঠিক
ঠিক
আছে
আছে, সারফেস রিপ্রেজেন্ট করবে। এক্স বেসিক্যালি তোমরা যদি প্লেনের ইকুয়েশন ওই ইয়ে করছো না, জেড এক্স ওয়াই দিয়ে আসে, ওখানে সারফেস পাবে, এক একটা সলিউশন মানে হচ্ছে সারফেস। ওকে, so you will have your u and you will find out, you have to find out any two, so it is your choice which two you will integrate. Sometimes it happens some is integration is easy than the other one. So next is, suppose I am, and there are, you know, sometimes you will need to multiply by a multiplier, and then I will, suppose I can write this as dx plus dy plus dz. You know this is equivalent to, right?
Yes,
This
ma'am.
will be, so if we take this is the integration of log x plus y, this will be, if we integrate, this will be nothing but log x plus yz, right? And I can find out this equating to there I can find out another u. Sometimes it may happen these equations are not so easy to solve, so we have to multiply by some multiplier so that our integration is easier. That is the only objective. Now suppose I am giving you, okay, try to solve this one. I am giving you a simple one. Zx(q) is equal to xy. So your Lagrange subsidiary equation will be dx by yz plus dy, this is dy is equal to zx dz by xy. So I can integrate, I can take this as dx by yz is equal to dy by zx, right? So z will be cancelled out. So your x dx minus y dy is equal to 0. So integrating, I will have x square minus y square is equal to c1. Okay. So find out the another one. This is also is very easy. And the another one will be same as if we take these two, this will be z square minus y square is equal to c2. So general solution will be okay, solve this one. Zxp plus zyq is equal to xy. Have I sent you the PDF for partial differential equation?
No, ma'am.
Okay. Okay. Solve these two and tell me what you got. I will send it.
ম্যাম ফার্স্টেরটা কি এরকম হবে, ফাই অফ এক্স বাই ওয়াই কমা এক্স ওয়াই মাইনাস জেড স্কোয়ার ইকুয়ালস টু 0?
Right.
ম্যাম ওটা এক্স ওয়াই মাইনাস জেড স্কোয়ার হবে,
xy minus
জেড স্কোয়ার বাই 2।
z square by 2.
হ্যাঁ
Okay. But here is this is z square xy minus z square is given. Check whether you have missed anything.
ওটা dz by x plus y into z হবে না?
Oh, sorry, this is with dz by x plus y into z, right? Fast integration is easy, right? And suppose I multiply mdx ndy mn and another is say pqrst I cannot use, so l dz, so this will be mx square plus ny square plus l x plus y into z. Sometimes we try to make this denominator is 0, so that whatever you got in this numerator, this will be equal to 0 and you can easily integrate. So we try to find out those elements, the multiplier, such that their sum is 0. So because you know you cannot integrate, this is in terms of y only, but you cannot integrate dz by x plus y because you cannot integrate this term with containing x plus y. So you have to use some multiplier such that either this becomes 0 or it becomes in a form such that you can easily integrate this equation with this. Okay, so now we have to find out some multiplier. So this sum is 0, x square.
Ma'am, if we take m as 1 by x, n as 1 by y, and that 1 by z, then we can.
Okay, so 1 by x, 1 by x.
But there is some subtraction, I think.
Okay, I think
Then
then
we have
there
to
will
do
be minus. I can
minus. Yes.
all will be minus. Something will be plus. Otherwise, that won't be
Yes.
cancelled,
Yes.
right?
Yes, ma'am.
So one term will be plus. This is z. So this is 1 by z. If we multiply with 1 by z, this will be x plus y. So these two terms will be minus 1 by x, minus 1 by y. So your term will be minus 1 by x dx, minus 1 1 by y dy plus 1 by z dz by this is minus 1 by x. You know this is 0. Okay. So now this is equal to dx by x square. Okay. So this equation is equal to 0. So integrating whatever what you get, this is equal to 0 means dz by z, dy by y, dx by x. So one will be plus, another will be minus log of this. Okay, C2. Right? So your solution will be phi 1 by x minus 1 by y, and if you choose you can simplify this, or another is z by x plus y is equal to 0. So all of the problems you will have in this chapter will be like this. You have to choose your multiplier, and sometimes it happens that suppose you have the equation as phi plus 3q is equal to 5z plus 10 y minus 3x. Okay. So Lagrange subsidiary equation will be dx by 1 dy by 3 dz by 5z. I am giving you types of problems so that there is all of the types will be solved by any one of them. So this is 3dx is equal to dy. So your y minus 3x is equal to c1. From these two, I have integrated 3dx is minus dy is equal to, so I have got y minus 3x is equal to c1. So I will put this y minus 3x is equal to c1 here. Otherwise, it won't be easily integrable. So I will get another is by dx by 1 is equal to dz by 5z plus c1. Now you can easily integrate this. Oh, I'm tan
ম্যাম
c1.
tan c1 হবে।
That is tan c1, right? Tan c1. So you can integrate. First you integrate this and equate. This will be what will be z plus tan c. So basically tan c means this will be constant. So this will be nothing but dz by log 1 by 5. Right, this will be 1 by 5 log 5z plus tan c1, and there will be another integration constant that will be 1 by 5 c2, and your left hand side will be x. So I can simplify this, and 5x, if we multiply by 5x minus log 5z, okay, so 5x minus log 5z plus tan c1, and tan c1 is y minus 3x. So I will put here tan y minus 3x is equal to c2. So your solution will be given by phi uv. Phi. And sometimes you can write this u is a function of some because since u are v related by a function, so sometimes you can write u is a function of v, or here I can write this is your u, v is a function of u. So I can write this 5x minus log 5z plus tan y minus 3x is a function of y minus 3x because function of u. There is this is another form of writing your solution of PD where one you have got the second one from the first one. Your suppose your u is here, your v is here, so your v is phi u. Okay. Solve it. This is dx by 1 dy by 1 is equal to dz by Have you solved the first one?
Yes, ma'am.
What is the solution?
Sir, phi of x minus y, comma x plus y plus z plus 2 multiplied by e to the power minus y.
One is x minus y, another one is
X plus y plus z plus 2 multiplied by e to the power minus y.
okay. Everyone is satisfied with the second equation, second solution. Okay. What is the second for you? Z square. Okay. And how did you get this z square? This is very. You have to this one and x plus y. So how did you integrate? So I have to check. Otherwise, I cannot tell. And any other solution? This is common for all of you, I hope. And any other options for second solution? I have a doubt with this e to the power minus y. Otherwise, it's okay. If I sum this dx plus dy plus dz, so this will be x plus y plus z plus 2. So those it will be, if we integrate, this is e to the power y. How did you get it this?
ম্যাম আমি ওই অয়েলারের যে ফর্মুলাটা আছে মানে লিনিয়ার ডিফারেনশিয়াল ইকুয়েশনের সেরকম একটা ফর্ম এসছে, তো সেইভাবে সলভ করে ই টু দি পাওয়ার মাইনাস ওয়াইটাই এলো।
আচ্ছা তুমি একটা কাজ করবে, আমাকে তাহলে এটা ছবি তুলে পাঠিও। আমি মানে তুমি যদি কোথাও যদি প্রসেস ভুল না করে থাকো তাহলে ঠিকই আছে, কোনো অসুবিধে নেই। কিন্তু আমি জাস্ট ভাবছি এখান থেকে ইন্টিগ্রেট করে কিভাবে এলো আর কি। টু দি পাওয়ার মাইনাস ওয়াই মানে তোমার কোথাও একটা লগের
হ্যাঁ ম্যাম
ছিল।
এটাই এসছে, ম্যাম এটাই এসছে,
ম্যাম যে কোনো দুটো dy
এটাই এসছে,
ইকুয়ালস টু
এটাই
dz
এসছে।
বাই x প্লাস y প্লাস z করলে ওটা ওই লিনিয়ার ডিফারেনশিয়াল ইকুয়েশনের মতো ফর্ম চলে আসছে,
ও
যেটাকে
আচ্ছা, দিয়ে এটা
ইন্টিগ্রেটিং ফ্যাক্টর দিয়ে গুণ করে।
করেছো। আচ্ছা ঠিক
হ্যাঁ
আছে,
এটাই আসে, ঠিকই আছে।
ওকে ঠিক আছে। কিন্তু তাহলে জেড স্কোয়ারটা কোথা থেকে এলো? জেড স্কোয়ার একটু ইয়ে রয়েছে, ডাউট রয়েছে জেড স্কোয়ারে। আচ্ছা হ্যাঁ, সেটা তুমি এল কি দিয়ে গুণ করেছো আবার বলো তো, কি দিয়ে? ঠিক আছে, আচ্ছা এবার সেকেন্ড ওয়ানটা ট্রাই করো।
ম্যাম একটা কোশ্চেন আছে।
বলো।
ম্যাম বলছি এরকম যে ফাই অফ ইউ কমা ভি যে ফাংশনটা বেরোচ্ছে না, ওই ভি ফাংশনটা তো মানে ভি মানে যেটা রিপ্রেজেন্ট করছে ওটা তো ম্যাম বিভিন্ন ফাংশন আনা যেতে পারে তাই না? মানে এখানে যেমন একটা এক্স প্লাস ওয়াই প্লাস জেড প্লাস।
এক্স্যাক্টলি এটার মানে এমন নয় যে তুমি এবং তোমার বন্ধু একই ইয়ে পাবে। আর তুমি কোন দুটোকে ধরেছো সেটা তো তোমার উপর ডিপেন্ডেন্ট না। কিভাবে তুমি কোন মাল্টিপ্লায়ার দিয়ে মাল্টিপ্লাই করেছো, রাইট?
ঠিক আছে ম্যাম।
ওটা একটু ডিফার করতেই পারে, অসুবিধা কিছু নেই। এটা দেখো একটা জেনারেল সলিউশন বেরোচ্ছে। তুমি যখন পার্টিকুলার ওই আরবিট্রারি ইয়েতে পার্টিকুলার কোনো ভ্যালু দেবে তখন আসলে পার্টিকুলার সলিউশন হবে। আচ্ছা এবার সেকেন্ড ওয়ানটা ট্রাই করো। আর আমি তোমাদেরকে পিডিএফটা পাঠিয়ে দেবো, তাতে দেখবে এক্সারসাইজে অনেক টাইপের অঙ্ক করতে দেওয়া আছে। ওখানে 4টে রুল বলে সলভ করার আছে, কিন্তু প্রত্যেকটাই দেখবে এই 4টে রুল এর মধ্যে কভার হয়ে গেছে। একটা রুল মাল্টিপ্লাই।
ম্যাম সেকেন্ড ইকুয়েশনটা আসে হচ্ছে ফাই অফ এক্স কিউব প্লাস ওয়াই কিউব,
দাঁড়াও, ফাই অফ এক্স কিউব প্লাস ওয়াই কিউব
কমা জেড বাই এক্স মাইনাস ওয়াই,
জেড বাই এক্স মাইনাস
ইকুয়ালস টু 0।
ওকে, বাকিরা সলভ করে বলুক কি বেরোচ্ছে। হ্যাঁ এক্স কিউব প্লাই ওয়াই কিউব তো গোড়া প্রথম দুটো থেকে পেয়েই যাচ্ছ, ফাইন। মাইনাস মাইনাস ওটা উঠিয়ে গেলে হ্যাঁ ঠিক আছে। এটা ঠিক আছে। বাকিরা সেকেন্ডটা সলভ করলে? সেকেন্ডটা হয়েছে বাকিদের?
ম্যাম লাস্টেরটা তো এসছে।
ওকে, ঠিক আছে, আমি তোমাদের পিডিএফ পাঠিয়ে দেবো, ওতে দেবে এক্সারসাইজে আরো অনেক অঙ্ক দেওয়া আছে, তাহলে ফার্স্ট অর্ডার পিডি তোমরা সলভ করতে শিখে গেছো। ওকে, আজকের মতো এটুকুই থাক। And Merry Christmas to you, all of you. অবশ্য এই ক্রিসমাস কেমন হবে জানি না। তো ওকে, নেক্সট 31st এ 10 AM ক্লাস নেব।
ওকে ম্যাম।